VXLAN EVPN deployment. In today's lab, we will dive into the implementation of VXLAN EVPN within a data center environment. We'll focus on the underlay OSPF routing and multi-pod configuration. As you can see, DC1 in here, we have two pods. Pod 1, ES number is 100. Pod 2, that's ES number 110. We are running OSPF for underlay routing. The underlay network forms the fundamental IP infrastructure that facilitates the VXLAN tunneling. It's OSPF is employed as the routing protocol for the underlay during this efficiency to dynamic route this discovery and scalability. So OSPF will enable each network device to discover, maintain, and a comprehensive map of a network topology. The most important, you discover all the VTAPs, okay, in this network. Secondly, you will see there's a pod 2, pod 1 is a multi-pod architecture. It extends the data center scalability and flexibility by interconnecting the multiple pods, distinct network segments. So over this an IP-based underlay. Okay. Each pod will operate as an independent VXLAN fabric. There's a fabric. It will be a fabric. They are interconnected to perform a cohesive and a larger fabric together. This design will allow efficient resource utilization and a simplified management. For the data plane and the control plane, what is data plane? Data plane is responsible for actual forwarding the user data packets in a context of the VXLAN EVPN. And the data plane will handle the encapsulation and decapsulation of the VXLAN and EVPN packets. So they are traversed under the underlay network, which is OSPF. Okay. Then what I talk about is control plane. So control plane will manage the exchange of routing and reachability information. So in SLAB, the control plane we'll use is called EVPN. Ethernet VPN to distribute a MAC and IP address. These are going to be distributed across the network. And all the devices have the necessary information to forward traffic efficiently across the network. So we have underlay is OSPF. And in the underlay, and we implement the multi-pod, pod 2, pod 1. This will achieve a scalable and resilient, efficient VXLAN deployment. So lab will provide a hands-on experience and in a setting up and a verifying of this configuration. So I will ensure you understand the modern data center network in this DC1, this part. Okay. So now let's dive in my first node, DC1 spine. We're going to enable few feature. We'll enable OSPF, feature, PIM. For now, that's it. will enable two feature OSPF and ping. Okay. Well, first enable OSPF 1, the route ID. We need a list route ID, which is my loopback 0. So, well, description that is used for V tap IP and IP address. We'll give a tag first, 1, 2, 3, 4, just for now. IP router OSPF1 area 0. And I enable ping IP ping sparse mode. Okay. Show run interface loopback 0. Here you go. And interface loopback 1. We're going to use the loopback 1 as my RP address. IP address, IP router OSPF1 area 0, IP ping sparse mode. Okay, show run interface loopback 1. Here's my loopback 1. And I missed one thing, is a loopback interface loopback 1, IP router OSPF1 area 0. Oh, how can I type a run? Now here you go. Now this time I'm doing a few times for my DC facing interface. Is a 1/2, 1/3, 1/4. Okay, so interface through Ethernet 1/2. We'll make no switch port. IP address 10.1.1.1. No shutdown. Interface 1/3. IP address. Okay. And we'll have to enter Ethernet 224. We're doing some IP router OSPF 1 area 0. IP ping sparse mode. IP OSPF network type. This point to point. I don't want a DR BDR, just make a point to point because it's just leaf and spine directly connected. No shutdown. Show run interface. You want 2, 1, 3, 1, 4. Now they are connected and they are configured. What's next to configure is IP ping RP address. You have option to configure and anycast RP. We don't have multiple spines, so that's fine. We'll do is IP ping RP 100 RP address 100 1.1.1. That's it, and my RP is serving for all the groups in multicast. Verify that, show IP OSPF interface brief. Show IP OSPF interface brief. Show IP ping interface brief. Okay, now we're going to move on to my leaf 1. Leaf 1 is the same. I'll have to first enable feature ping. feature OSPF, for router OSPF, 1, router ID 2.2.2, exodus, interface rollback 0, IP address 2.2.2, 32 IP, router OSPF 1, give a description, that's vtap IP ping, sparse mode, that's only rollback we need in this case. For the next, we're going to configure my interface 1.1. Okay. IP router OSPF 1 area is 0. You can make a name like Underlay. For here, I just use a 1. You can make a name, IP ping, sparse mode, no shut. Show around interface U11, IP ping neighbor, show IP ping neighbor, show IP OSPF neighbor. It's creating the interface neighbor, IP OSPF point to point. So the neighbor will create it. Well, don't worry about it too much. We're going to just continue to configure my RP address. Show around pin. Show IP OSPF neighbor one more time. Is in full state. Save it. Well, it doesn't take a WR. Just copy this command and it will save my config. Let's move on to my DC leave 2 feature pin, which is in this node. Feature OSPF. Now, router OSPF 1, router ID, interface rollback 0, IP address, IP router OSPF 1, area 0, IP ping, sparse mode. Now I'll take up the interface to my spine. No switch. There you go. Show IP OSPF neighbor, IP OSPF network, point to point. Lastly, we'll see I'm using IP ping RP address 100. One. Do IP OSPF neighbor. Show IP ping neighbor. Here you go. We've been taking care of the DC1 part 1. Alright, DC1 part 2 spine. Part 2, we're still going to use ping. OSPF. router OSPF1 router ID interface loopback 0, but that's my VTAP. IP address, IP ping, sparse mode, back to this. Now let me take out my two interface. Interface 1, no switch port, IP address, interface 1, 2. Okay, and my RP will still be my DC1 spine 1. IP ping RP address. So IP ping neighbor. Okay, so lastly is my port 2 leaf. You're gonna be feature ping OSPF router OSPF1 router ID. Okay, IP router OSPF1 area 0 IP router OSPF network IP OSPF network point IP ping sparse mode no chat IP ping RP address show IP OSPF neighbor show IP ping neighbor show IP route OSPF 123 212121. Here you go. I have all the routes. OSPF underlay is created. We're taking care of overlay. We're using MPBGP. So navigate back to my, DC1 spine 1. The first thing I'll do is to enable MV overlay EVPN. Is to enable the VXLAN EVPN control plane. Then feature BGP. So router, I know my DC is using AS100. So router OSPF router BGP 100. Okay, that's neighbor 2.2.2. My leaf 1, remote AS 100, update source, loopback 0. Make sure I use address family AF2 EVPN. This MAC to VTAP mapping we're using instead of the IP routes, IPv4 we're using EVPN. So send community extended community has RT values. We're sending the MAC address to VTAP, IP to VTAP mapping table. So for example, this gonna send type 2 were included in this community. Okay, it's gonna become an RR. So next neighbor 333 remote. I'm doing all this manually. I don't copy, I don't paste. There's no automation. This all manual. So you get you familiar with all the lab commands. I have add a video that's for NDFC automation, single plane of glass. You take a look at the lab videos also. I'm doing this all for manual. So two neighbors for my leaf 1 and leaf 2. This is gonna be my spines, and these are my RR EVPN neighbor. Save that. Now go to my DC1 leaf 1. DC1 leaf 1 will enable NV overlay EVPN. Feature. Features. What a feature. VN segments VLAN based. The first command is to enable VXLAN control plane EVPN. The second command is feature VN segment VLAN based, is to enable VLAN based VXLAN mapping. VXLAN will have a VLAN ID. So next feature NV overlay. I talk about this to enable VXLAN NV overlay. So router BGP 100, router BGP 100. Did I enable feature also? BGP router BGP 100 neighbor is 111. My spine 1 remote OS AS 100 update source loopback 0 address L2 EVPN send community extended. Okay, that's what we configured. We want to take a look. You could use Underlay. We'll talk about. So I just thought about this. In this case, you can use Underlay or SPF. I'm using it, and also you can use IS. You can use even BGP. You can use BGP for Underlay. How it gonna work? So this is span. It's gonna be AS. Leaves is gonna be AS. For them to connect, it's gonna be a BGP neighbor. So these are the three underlay protocols, and there will be eBGP if you use BGP for your underlay. Alright, continue on my lab. DC1 leave 2 NV overlay EVPN will enable VXLAN control plane EVPN feature BGP feature NV overlay router BGP 100 neighbor remote AS 100 update source loopback 0 address family L2 EVPN send community extended extends or send community has RT values. I will send the MAC to VTAP, IP to VTAP table. Right. Show run BGP. Go to my spine one. Show BGP L2 EVPN summary. I have two EVPN neighbor established already. Save my config. Save my config. Now move on to my part 2 spine. Part 2 spine is going to enable feature NV overlay EVPN. Will enable overlay EVPN control plane feature BGP router BGP 110 different AS. Then part 1 neighbor on link to 22222222. My part 2 leaf remote AS is 110 update source loopback 0 address family L2 EVPN send that community extended with RT MAC IP to VTAP, right? And router we're gonna still become a refactor unit, just my only neighbor, BGP neighbor. Save that config. Move on to part 2 leave. We're gonna enable 4 new features. Overlay EVPN, enable that VPN control plane. Feature is BGP. New feature NV segment, VN segment, virtual network segment VLAN based. Feature NV overlay. So that's commands. Feature VN segments VLAN based is doing a VXLAN mapping, and this feature will enable VXLAN. Router BGP 110 router ID 22222222 neighbor 212121, which is my part 2 spine. Part 2 spine remote VS 110 saying IBGP saying AS loopback 0 update source address family L2 EVPN send that community extended Save it. Now go to my spine, show IP BGP L2. No IP, just show BGP L2 EVPN summary. Neighbors up. And also go to my spine one, double check show BGP session. Here you go, sessions established. My leaf 1 and leaf 2 on my part 1. In part 2, show BGP session at 1 leaf, which is up. So at this stage, we'll configure first is OSPF part 1 and 2. Second step, we configure EVPN part 1 and part 2. And part 1 and part 2 because they are separate control plane. The third step we're taking care of is the VXLAN. This step is the last step where majorly configures on the leaves. Okay, leaves is part 2 leaf, part 1 leaves, and when taking care of the server interface. Okay, this step we're taking care of is the VRF, the tenant, the MVE interface. Anyway, let's get onto it. The step will be implemented in the leaf. So DC1 leaf 1 feature, of course, we have new feature to enable is feature inter VLAN. It's the feature to enable SVI interface. Like, interface VLAN 100, interface VLAN 101, etc. The next feature we'll have to enable is called, okay, it's not a feature, it's called Fabric Forwarding Anycast Gateway MAC address. Well, make a MAC address is like 00022223333. So it's to enable an Anycast gateway consistent MAC address. Okay, it's used for VLAN to VNI. My client show ARP. You will see the gateway IP as this MAC address, showing the MAC address like this. Okay, so what I have to create is VLAN 100. The name is gonna be L2VNI1. It's gonna be L2VNI. We have VLAN 100. Okay, next VLAN 110. We'll give a name L2VNI2. Okay, forget doing this. We and 100 go back to here. VN, we're gonna segment 10100. VLAN 110 VN segment 10 VN segment 10110. Next is VLAN 111. Name is gonna be my L3 VNI VN segment 11111. So now show VXLAN. This is the mapping for VLAN and the VXLAN ID, VN ID. Okay. The next job is to enable ARP suppression. We don't do it here, that's fine. So we are gonna to adjust TCAM table resource, which it will be like this: TCAM. We reduce VPC convergence to 0 and the hardware access list TCAM region ARP 256. It needs a reboot. We don't need to do that first. So let's do add a parse content VF. We create a tenant. We say tenant one. Tenant one. We use VNI 11111. This L3 VNI RD. Say auto. Okay. Address family IPv4 unicast. Okay. So route target both auto. Route target both auto EVPN. Okay. Interface VLAN 100. Now I'm creating VLAN 100. No shut. VF member is gonna be my tenant one we just created, right? IP address 192.168.1.254//24. Then we say this is gonna be fabric forwarding mode Anycast gateway. It's my Anycast gateway. Okay. Next Anycast gateway VLAN 110. The other VNI, no shut. We have member tenant is one. Fabric forwarding mode Anycast gateway. Okay. Also, don't forget the IP 192.168.1.254/24. Show run interface VLAN 100, 110. Okay, two Anycast gateway interface VLAN. Next, we require is another interface for my L3 forwarding. We have member tenant 1, no IP redirect, IP forward. Show run interface VLAN 111. So this is L2 to L2 routing, right? We need L3 interface VLAN. L3 VNI is to forward, so there's no IP needed. Next, we're going to create a interface NVE1. What is this? Interface is an interface NVE used for decap and encapsulation of VXLAN packets. With no shut interface, host reachability protocol, we use BGP. Okay, we use BGP. We use BGP EVPN control plane. So source interface is going to be rootback 0, and member VNI 10.1.1.0.0. You will know it's my one of my L2, L2 VNI, So I will use AMC multicast. I use multicast group 225.1.1 to forward the bomb traffic. So member VNI 10110. That's another L2 VNI. Send group, that's fine. Member VNI 11111. That's L3. Remember L3 VNI. Associate VF. Show run interface MVE MVE1. Here you go. For the next job, we're going to enable EVPN. Is to define RD table, RT. Okay, it's for my L2 VNI RDRT. I will make a bridging in the same VNI. So how do I do that? So VNI I have is 10.1.0.0.0. It's gonna be L3, L2. Okay, so L2 RD will make assign to auto route target import both auto. Next, VNI 10110. So we're taking care of two L2 VNI. RD auto, route target, both auto. So show run EVPN. Show run BGP. To the end, well, I can see I'm taking care of the L2 VNI. So lastly, so we'll go to interface E12 with no switch ports, switch access VLAN 100. Okay, no shut. So this is to my server ports, DC1 server, internet 1. Okay, I will assign to VLAN 100. Show VXLAN one more time. Here is the mapping. Leave 2, I would do all the same on this node. Feature, inter VLAN, fabric, forwarding, and cast. Okay, VLAN 100, name L2 VNI 1 VN. This command doesn't exist, that's fine. Show run features. So we'll need feature VN VLAN based feature fabric forwarding. Let's try that one more time. VLAN 100 name L2 VNI 1 VN segments good 10.100 VLAN 110 name is L2 VNI 2 VN segment 10110 VLAN 111 name is L3 VNI VN segment 111 my L3 VNI hardware access TCAM region PC. I have to reboot after, that I'll do later. So VF tenant tenant 1 VNI my L3 VNID RD auto address. That's my IPv4 unicast route target both auto route target both auto EVPN. Okay, interface VLAN 100 no shut VF member tenant 1 IP address. Interface VLAN 110 no shut VF member tenant 1 IP address. Fabric forwarding mode and cascade gateway. My interface VLAN 111 L3 no IP needed. No IP redirect IP forward. Next is my interface MVE1 host protocol will be BGP, source loopback 0, member VNI 10100, MCAS group, member VNI 10100, MCAS group. Okay. Member VNI 10110, MCAS group. Okay. VNI 111 associated VF. I'm sure that if I use a different group for this, okay, I think I use different groups, so go back to my to run my leaf one. I'll change it. Show run interface MVE1. Okay, I'll change. Show run interface MVE1. Okay, it's changed. Go back to my leaf 2. We should continue. Now show run interface MVE1. Show run interface MVE1. Okay. Next is my EVPN. VNI 10100L2. RD auto. Route target. Both auto. VNI 10110. L2. RD auto. Route target. Both auto. It shows me unable to generate the RD, which will have to take a look. Why? Should run VLAN. I temporarily don't know what it is, but let's do it. C13. No, I have to assign a VLAN. Switch access VLAN 100. No shut. Just for my PC 10 and 1 in DC1. Next, navigate to Part 2 leave. Pot leave St. George. I have to feature interface VLAN. Feature forwarding. No, it's fabric forwarding and cast. VLAN 100. Name is L2 VNI 1. these are all the same drawer. I just keep typing what I require here. Please follow me. I'm doing DC1 part 2 leaf. Okay, let's now do some test. I'm testing from the PC 1 to the server 1 across the fabric. Or ping the server T1 internal 1. I'm pinging my own gateway. It's good. I tested before. I testing to ping the PCT1 is succeed. Um, my gateway successful. So let's take a look at my leaf 2. Leaf 2, if I show BGPL2 VPN EVPN, okay, 192.168.1.111, I can show a record. I see a record type this records right here, and this is my type 2. That's used for the MAC and ARP and the routing of the hosts. Okay, where is record from? TN RT extended community. I talk about this, right? And it's from my VTAP, which is my leaf 1. Again, I could show show the same thing on the MAC address, which is here, MAC address. See, I can find out. It's showing the same. Now go to my leaf 1. I will show you is show the L2 VNID. I will see the L2 type 2 records in here. The information of the host. Okay. Right here in leaf 2, I can see advertise the EVPN route contains the RD, right? RD and RT. It has the VPN target. also known as the root target, right? The RD is used to differentiate the different VXLAN EVPN routes, and our VPN target is BGP extended community attributes. It used to control advertisement and receiving of the EVPN routes. So that's the VPN route defines the peers that can receive EVPN routes from local as well as whether it's local ends can receive the EVPN routes from the peer. The layer 2 targets, VPN targets, we have is the RT100 AS number and my L2 VNI, and LRT is the L3 VNI.